This video is for topic 3.2, Relations and Functions, day 2. So on day 1, I know that was a long time ago, but we talked about Dr. XY, so domain and range go with X and Y. So domain goes with X, range goes with Y. The bell work wants us to write a compound inequality to represent x, where x is greater than 2 and less than 7. So where x is greater than 2, so remember the greater than goes to the right, but x is less than 6. I'm sorry, I think I said 7 earlier. Less than 6. So for this, what we could do, remember if we wanted to fully switch everything, we could switch the 2, the sign, and the x. Now if you notice, I could write on my answer 2 is less than x, and then this part over here in red, if I tack it on, x is less than 6. So this x in the middle is being shared. X is between 2 and 6 is another way to write that or to say that. So x is greater than 6 and 2 is greater than x. So less than. 2 is less than x is less than 6. So we write it all together. 2 is less than x, which is less than 6. That is called a compound inequality, where you take two inequalities and put them together on the same line or on the same graph. Problem 2 in the bell work is another compound inequality. X would be between -2 and 6. From -2, it is getting bigger, and then it has to be smaller than 6. At -2, we do have that line under the inequality because the bubble is filled in. So x is between -2 and 6. X is between those, and because x is between those, if we will always write least to greatest, you will always use less than signs. So if you write least to greatest, then you can use less than signs. And then I drew out the less than sign for you to remind you that the less than looks like a little slanted L. The other sign that goes the other way is the greater than. On all of your standardized tests, they will be written least to greatest with less than signs, so anytime that it is necessary, that's what we are going to use. Problem 1, they ask us to find the domain and range, so remember Dr. X, Y. So domain goes with X, range goes with Y. When we list out our domain, because these are all separate points, our domain is going to consist of separate X values. We have this one over here. You don't have to draw arrows. I'm just going to draw it so you can see what I'm pointing to. This X over here is at -8. This X here is at -5. This one is at -1. That one is at 4. And that one is at 8. Remember, we are looking on the x-axis. Our x-axis goes left to right. Positives are to the right. Negatives are to the left. Looking at my y's, my y-axis is the one that goes up and down. Up is positive, down is negative. So if you go down, make sure you put those negatives. So if I'm starting bottom to top, this one down here is at -7. And remember, because my points are all separate, distinct points, I have to use the braces or the squiggly lines. This y value right here is down at -5. This y value is at 0 because it doesn't go anywhere up or down. This one is at a +2 because it goes up. This one is at a +5 because it also goes up. If you want, you can write a table out to the side. You could do a table like over here or over here to write out all of your points and then rewrite your domain and range. Remember, we don't do repeats. So even if it is repeated, we do not repeat it. So for problem 2, domain is still x's and range is still y's. I'm actually going to do it in a different color. Domain is still x's and range is still y's. However, this time, instead of having separate distinct points, we have everything on this line to account for. All of these little points, all up in here, are all x's. If we tried to list that out, it would be a lot for us to have to list. So instead, what we're going to do is write a compound inequality like we did up here to include all of my x's from the least to the greatest. So what I'm going to do is write out my points. This is the point -8 because I go to the left, +1 because I go up 1 on the y's. And over here, this is the point 2, -4 because I go 2 to the right and then down 4. So if I'm looking at my domain, remember domain deals with x values. Points are written x, y, so it's alphabetical. For my x's, I have a -8 and a +2. As I wrote up here, if we write least to greatest, then we can use less than signs. So looking at my x's are -8 and 2. My lowest is a -8. My highest x value is a 2. So I put the least over here, or the lowest, and then the greatest over here. Because I did least to greatest, I can use less than signs. X is going to go in the middle like we did with the compound inequality. The only other tiny little thing I have to remember is at both of these spots, I have filled in bubbles or points, filled in points. So I have to put lines under the inequalities. If we follow the same method with my y's, again, I'm going least to greatest. My y's, I have -4 and +1. My least is going to be -4 because anything negative is less than a positive. My greatest is 1. Both of these bubbles are filled in bubbles, so we're going to put the line under the inequality. And again, because I went least to greatest, I can use those less than signs. Another thing you could do would be to draw, like those would be my y's, this would be my x's, and kind of make a box and figure out least to greatest in that box. I find it easier to write the points out so I can see exactly what I'm dealing with. So for problem 3, again, I'm going to write my points. So this is the point 4, 6. We go to the right 4, so it's positive. We go up 6, so it's positive. And this is the point -6, -2. So we go left 6, down 2, so they're both negatives. Okay, again, remember Dr. XY. So domain is X, range is Y's. For the domain, looking at my X values, I have a 4 and a -6. Remember, we always go least to greatest. And if you want, what you could do before solving any of these problems, this middle is always going to be the same. You're always going to have less than X less than and less than Y less than. So if you wanted to, you could go ahead and set that up and then fill in your numbers and figure out if any of them need a less than or equal to sign. So my least on the x's is -6 because -6 is smaller than 4. My greatest is 4. And at the point of 4, I have a filled in bubble, so I have to do a less than or equal to sign. Least to greatest on my y's would be -2 and +6, so those are my y values. My least would be the -2. My greatest would be the +6. And again, at 6, I have a filled in bubble, so I have to put the line under the inequality. This is something that truly requires a lot of practice. The best way to get this down is to look at all those rules, take it slowly, and finish your assignment to make sure you know what you're doing. On problem 4, again, I'm going to write out my points. This point over here is at 1, 2, 3, 4, 5, 3, because I go up. I go positive 5 to the right and then positive 3 in the up direction. This point over here is at negative 3, negative 1. So again, I'm going to look at domain is my x values, range is my y's. So for my domain, I have negative 3 and positive 5. So least to greatest would be negative 3 less than x less than 5. Both of these bubbles are empty, so I leave them without the equal sign underneath. Looking at my y's, negative 1 and 3. So least would be negative 1, greatest would be 3. And again, I use less than signs, and range is your y's. So if you will write out your points, it's a lot easier. So problem 5 is a multiple choice problem. It asks us the function f is graphed to the right. What is the range? So first thing I need to remember, range covers my y values, which means I can automatically mark out A and B. Neither of those have y, they have x, and it's not x that I'm looking for. Now if I look at C and D, these both have the same numbers, so I'm probably going to assume that that's correct. The only difference is where that line under the inequality goes. Does it go when y equals 3, or is it when y equals negative 3? So let's come and look. Remember, this is your y-axis, so when y is a positive 3, it has an empty bubble, meaning when y is 3, it does not have the line under the inequality. When y is negative 3 down here, it does have a filled-in bubble, which means we do need the line under the inequality. So that would be answer choice D. Now problems 6 and 7, we're still finding domain and range, but these look different. These problems are rays. They have a point and then an arrow with no distinct end point. So we have to write these a little differently. We're still going to find the point. So this is the point, negative 3, 2. We go to the left 3 and up 2. Negative 3 is going to go with my domain. 2 is going to go with my range, because remember, domain is my x values, range is my y's. Now this time, because I only have one bubble, I'm only going to have one inequality. Something that students do to help is to try to frame that arrow, that ray that you have, with an x and a y. So we're framing the arrow. The arrow needs to be in between. And we're just giving it like a little bit of a picture. Now here, this arrow up here on the top is the direction of my x's. My x's are going to the right, and the right is greater than. So if my x's are going greater, then on my domain, x needs to be greater than negative 3. And then remember, there's a filled-in bubble, so we have to do the arrow or the line under the inequality. Looking at my other frame, the up and down is my y's. My y's are continuing to go down. On the y's, when you're going down, that is less than, so my range would be less than or equal to 2. So if you frame your arrow, then things get a little bit easier. On problem 7, when I frame this arrow, so I'm going to draw one arrow coming out and one arrow coming out from the same bubble. Remember, the arrow that is drawn needs to be in between your arrows. So for example, if I did it incorrectly and drew my arrow over here, there's no line here, so that's not the correct way to draw it. You're framing the arrow that is already drawn. This point is the point 5, negative 2. Domain is my x values, so x and 5 are going together. Range is my y's, so y and negative 2 are going to go together. Now, when I follow my arrows, my x-axis is the one that goes left to right. This arrow is going to the left. On the x's, remember, if you go left, that is negative, so it is getting less than. You can also remember, just like we talked about earlier, on a number line, when you go to the left, it is less than. My y's on this arrow are going up, meaning my y's are going to be greater than -2. They are increasing. This bubble is empty, so we do not put the line under the inequality. Problem 7 asks us which graph shows a function with a domain of all real numbers greater than 7. So remember, domain is my x values. Greater than means it's going to go this way. And then 7. So we are looking for where x is getting bigger than 7. On A, x starts at 7 and then goes 8, 9, 10. So that one looks pretty good. It is getting bigger than 7. On C, my domain is starting at 0 and then going 1, 2, 3, 4, yada, yada, yada. But that's not 1, 2, 3, and 4, 0. Those are not bigger than 7. D, x is starting at 7 and it's staying at 7. Remember, we're looking at our x values, so it's not going anywhere left or right. And similar situation with B. X is starting at 7, but it's not going anywhere on the x's. So A would be my correct answer for this problem.